Well, grade 10s, 11s, 12s, welcome back. We're going to be continuing with inequalities. What we said in the previous lesson was if you divide or multiply an inequality on both sides by a negative, the inequality sign changes its direction. If you do it with a positive, it's not going to matter. Now look at another one in grade 10s. Oh, this is important. You've got to solve for x and represent on a number line. Now my problem is I've got two inequalities. Okay, I firstly need to get rid of something. I want to get rid of that 2. Now the best way to do that is to, if you think about it, if I subtract a blue 2 there, I'm going to get rid of that 2, but I can't just do it to there. I must do it to the right and to the left. So I subtract 2 from everybody. Okay, minus 4 minus 2 is minus 6. Okay, 2 cancels with 2 and we still left with minus 2x. 6 minus 2 is then 4. Okay, now be very careful. Please don't get this wrong, guys. You're now going to divide by, look at this, by negative 2. And when you divide by a negative, these inequality signs are going to change direction. Now watch this. If I divide negative 6 by negative 2, I get 3. If I divide negative 2 by negative 2, well, it cancels, and I get 1. 4 divided by negative 2 is negative 2. And notice, the less than becomes a greater than. The less than or equal to becomes greater than or equal to. Now, what I'm going to show you, when you represent this on a number line, be very careful now. What you're doing, people, I'm going to say, we don't like this order. Minus 2 must go first. Now, would you agree that 3 is bigger than x and x is bigger than minus 2? So if we reverse it, minus 2 is going to be the smaller one and 3 is the bigger one. So we simply rotate that thing around. Okay, and if you like, you can then go to a number line. Now notice, the big number goes here, the 3. You don't even need this step, by the way, that second step. You don't even need this. If you've got this, the minus 2 goes first and the 3 comes then. Remember, it's an open dot on the 3. You're not including the 3, but you're including the minus 2. And you put a solid dot there and you go in between. With these guys, you're always in between. Okay, so don't go away. Now, grade 11s, we need to focus on something else. So I'm going to develop this very slowly now. I don't know if you've done this. It's called the quadratic inequality. Now watch this. You know from grade 10, a parabola, a happy parabola, looks like what I've got there. And you'll remember if we, for example, take x squared minus 1. Remember fx, y equals x squared minus 1. The parabola, I'm not going to put the y-axis in now, but the parabola cuts the x-axis and you let the y, the fx, be naught. Now it's very easy. It cuts the x-axis there, and we want to get those x values. Now when you're given this little quadratic equation thing, or quadratic graph, a parabola, if you put the y equal to naught, so you put it equal to naught, you can get yourself a nice little quadratic equation. So you factorize with difference of 2 squares, and if you remember from grade 10, x is minus 1 or x is 1. Now these guys are the x-intercepts of the parabola, and we can draw and we can put them in there. Okay, so you've got your x-intercepts. Now these are very important values that we can use. So that's where it cuts the x-axis. So now I'm going to develop this very slowly, and I want you to listen very carefully. People, once we've got that, I'm going to ask some questions, and I'm going to cover all the angles of questions. Now watch this. It says there, for which values of x will the parabola cut the x-axis? Okay, in other words, that's where the parabola equals naught. Now we've already worked out our little x-intercepts. We had x squared minus 1, y equals x squared minus 1. So it's a happy chappy. Remember, y equals x squared, the number next to x squared is positive. It's happy. You probably remember this from grade 10. Okay, so we're always going to draw a parabola here. Okay, and we put our little values on there. Now keep it, just focus on the concept. For which values of x on the x-axis will the parabola cut the x-axis? Well, it cuts there and there. Close dots on those two values. So where does it cut? At x is minus 1 or x is 1. Remember, I'm using those two x values as an example. For which values of x does the parabola cut the x-axis? at -1 and 1, and there's your solution. Okay, now let's change a little bit. For which values of x will the parabola lie above the x-axis? Now listen to me carefully. The parabola is above. To the left of -1, it's lying above, and to the right of 1, it's lying above. So, and if you think about it there, it's going to be above there. In other words, to the left of -1, the parabola goes above. For all the x's to the left of -1, it's above. And it's above, and then we say x is less than -1. Now, likewise, if you've got this, if you're above, you're going to the right of 1, so x is greater than 1. So the answer, and also by the way we put open dots because we're not including, they don't want where it's cutting, they only want where it's above. Well, to the left there and to the right it's above. Okay, now the answer will be x less than -1 or x is greater than 1. Okay, that's so important. Above is the little thing, the two branches are above. Okay, let's look at number C quickly. For which values of x will the parabola lie above or cut? Now, that means we're equaling as well. So we can, it cuts the x-axis there and there. So we include those values, it's closed dots. And where are we above? Well, we're above to the left and to the right. Okay, and so we're going to the left of -1 and to the right of 1, and we summarize that to the left of 1, to the right, and if it's an equal there, we include those values. Now stay with us, guys. We're going to explore this in more detail in the next lesson.